Hello everyone, in today's video we are discussing about the data structure algorithm tree part. Tree part is very important for a data structure. So the tree parts we'll be discussing in this video. So tree, what is tree? Tree is a nonlinear data structure used to represent the data connecting, containing a hierarchical relationship between element. Tree is a collection of many element. That's the relationship between the element is hierarchical. There is a example, you can see the example and you can understand better by this example what is tree. You know, in a tree we are written element within a circle. The circle name is node. Okay, the parents node you will be called root node. Okay, and in tree there is some level 0, level 1, level 2, level 3, like that, many level if you need. Okay, and the connecting between the two node will be called edge. Okay, and this is called the internal node. This is in the between the two node, and the last single node is called leaf node. Okay, so this is tree, and we can find the height of a tree by the calculating, by the counting. We can count from the root node. This is 1 2 3, only 3 in this, and we can find 1 2 3 4. There is a 4, we can go up to 4, then the 4 will be the height. And we also find the height from the level in this tree, level 0 1 2 and 3, level 3. Then the height will be the level plus 1 is called height. Okay, we can find from height of a tree from this tree level. And a tree is a finite set of nodes. A tree have a finite set of nodes such that there is a special node called root node, that's the main parent node, and the child node is the remaining nodes are n greater than equal to 0 disjoint node, and the set will be the t will be written t1 t2 t3 tn, where each subset is a tree. Each subset t1 t2 t3 as a tree. The set t1 t2 t3 tn are the subtree of the root. This is called, you can let this is t1 tree, and this is t2 t3. This is also a tree, am I right? This is also a tree. So this is called a subtree, and this is called the main root tree. Okay, so basic terminology from this example. Root node is a, that's why we written here root node is a, and leaf node is d, e and z. The leaf node is d, e and z. Okay, and the remaining intermediate node means internal node, those are neither root node nor leaf node. So the intermediate node is called they are v, c, f. VCF is the internal node or intermediate nodes, and subtree is C, because in the C is also a tree. Okay, C is also a tree, and B is also a tree, we can say. After that, the degree, how to calculate degree of a tree. Degree of a node is equal to the number of children that knows. Degree of a node is equal to the number of children that the node has. The leaf node degree is 0. Okay, then we can also calculate from this example, degree of a node is equal to the number of children that knows. So this nodes, root nodes, number of children, how many children has this node, root node? 1 2 3 4 5 6. So degree is 6, and the leaf node degree is 0. Okay, then binarity. What is binarity? Binarity is a finite set of nodes such that either empty or consist a special node called root node, and remaining nodes are participate into two disjoint t1 t2, both of them or the binary tree is called the left subtree and T2 is the right subtree, like that. Binary tree is this type of binary tree. You have to make two children's from a tree, from a nodes. Okay, if you are node A, then the child children will be 2, only 2. Okay, not 3, not 4. This is called binary tree. Properties of binary tree. The maximum number of node in a binary tree level is 2 to the power I. I is the level number. Okay, the minimum number of node in a binary tree on any level is 1. You have to remember, maximum number of node in a binary tree of a height 2 to the power h means height, minus 1. Maximum number of node in a binary tree. Okay, and minimum number of node in a binary tree is 1, and the maximum number of node in a binary tree I is a 2 to the power I is the level number. Okay, then the minimum number of node in a binary tree of height h is h, minimum number of node. Okay, in a binary tree, if n0 is the number of node with z0 child and n2 is number of node with 2 child, then n0 equal to n2 plus 1. Okay, then this is the example. n0 means number of 0 child, that's called leaf node. 1 2 3 4 5 6, n0 equal to 6. Okay, and n2 means 2 childs have 1 2 3 4 5, 2 childs 5 and 6, so n0 is equal to 5 plus 1. This is the rules, this is the formula. n0 means number of 0 child from a node is equal to number of 2 child from a node plus 1. Okay, so this is the example of this types of binary tree. Now we are discussing about the types of binary tree. How many types are there in binary tree? Strictly binary tree at first. If each node has either 0 child or 2 child. Okay, if each node have either 0 child or 2 child, then that is called strictly binary tree. So you can see A have a B and C 2 child, and B have a D and E 2 child, and D, E, F, I, J have no child. There is a 0 child. Okay, and after that C have a 2 child, Z have a 2 child. So this is strictly binary tree. After that, complete binary tree. What is complete binary tree? If each node has either 0 child or 2 child, if a node with 1 child, it's always in the left child. The complete binary tree is like a strictly binary tree, but there is a new feature that's called, if a node with 1 child, then it's always in the left child. Okay, so it is like previous example, only this part is called strictly binary tree, and if any single 1 child is in this tree, then the tree will be in the left side. So M is in the left side of E. So this is complete binary tree. You have to remember this. This is very important of a binary tree classification. Then the full binary tree. If all the level have the maximum number of node, in every level you have to make maximum number of node, then the binary tree will call the full binary tree. So in level 1, the element will be 1 element. In level 0, element is 1. In level 1, element is 2. In level 2, element is 4. Because in level 1 we know 2 to the power 0. Okay, and B and C is the 2 to the power 1, then equal to 2, and this is 2 to the power 2, this is 4, the level is 4. Note extended binary 2 tree. Extended binary tree means 2 tree, also name is 2 tree. If leaf node are represented using square and internal node are represented by circle, then the binary tree will be called extended binary tree. You can see the leaf node will be written in square, and the other node, internal node, and the root node will be calling as circle, will be represented as circle. Then memory representation of binary tree. How to memory representation in binary tree in our computer, in our compiler? Okay, using array it's happening. We take example A, B, C, D, E, F, G, H, I, like that. Okay, at first there is a rules. There we know there is a level 0, level 1, level 2. Okay, this is level 3. Okay, then at first we have to write level 0 element, that's A. Then after that level 1 element, all element B and C, then we write B and C. After that we write level 2 element D, E, and the C will be denoted as null. Null character means there is no element. Okay, so C left side there is no element, so we have to write null, NU double L. After that the H element, that is in the right side of C. After that we have to write 3 level element. 3 level element in D, there is a null. Null means there is no element, so 2 null will be written in the 3 level element. Okay, after that F and G, and after that we have to write this null element 2 element, that's null means no element, so we have to write null 2 times, and after that H element null, left side null, we have to write null element. After that we have to write K. This is the memory representation of binary tree. You can obviously, this is very easy, you can understand this very betterly, because this is very easy things. Okay, so we can find any child index by using parent index nong k. Left child means 2k plus 1, this is for odd. Right child means 2k plus 2, this is for even. Okay, k is a parent index. We can find child index from a child index to her parent index number. Okay, by this rule, left child and right child. If right child index is 14, then the parent index will be what? By this formula we can find 2k plus 2, because the child right child is even 14, that's why the parent index will be what? By this example, by this formula we can solve this example. 2k plus 2 is equal to 14, because right child is 14 index. Okay, then the parent child will be the k. So what is the value of k? 6. So the parent index will be the 6. If a parent index is 271, then the left child will be, left child means 2k plus 1 formula you will be using in there, equal to left child. So the k value is 271, then 2 equal to 2 into 271 plus 1, then the left child will be 543 for this parent index 271. Okay, this is very easy. Memory representation of binary tree using linked list. How to represent a memory of a binary tree using linked list. Okay, this is also very easy things. If you have a tree like that, then you have to only write the node like this, like this. You have to make a square, then you have to divide it into 3 part, and after that in the middle you have to write the data or information or element value, and this is the left side, this is the right side. Then after that you have to write the left element here, right element here, and before you have to make 3 part of this node like that. You can also see in this example 12 is like that, then the 13, then 17 is like that. If you in the left side there is nothing, then you can write like that. Okay, this is very easy. You can make it by own. Okay, this is very easy. Expression tree. These binary tree are widely used to in mathematical expression called expression tree. Operator are in non-leaf node. Okay, and operand are in leaf node. The operator are in non-leaf node and operand will be in the leaf node. Okay, then the one example a plus b is plus is operand operator, plus is operator, that is in non-leaf node, and a plus a and v is operand, that's why it is in the leaf node. You have to write like that. This is the expression tree. Okay, then there is example construct the expression tree and traverse in 3 ways. Then you can make this example like that. At first you have to find what is the where is the bracket. This is curly bracket, this is curly bracket, this is curly bracket. Then the into is in the root node. After that you can divide it's to in the 2 part. Then plus will be in the internal node. After that a will in the left side and b and c in the right side, and b and c is between minus operator, then minus will be the in the internal node, and after that leaf node will be the operator. Okay, operator will be in the non-leaf node and operand will be in the leaf node. So all operand in the leaf node. So then d and t in the leaf node, g and h in the leaf node, f in the leaf node, and operator will in the non-leaf node. This is very easy. And after that second example is also you can do it's you own by your own. Okay, you have to divide this is in 2 part, and the divided function you can modular function you can write in the root node, and after that you can make this, and also the all operand you have to write in the leaf node, and remaining the all operator will be written right in non-leaf node. Then after that there is a example tournament on selection tree. This is called selection tree. It is the concept of represent the winner and his way of winning the tournament. Later knockout Super 8 stage of a T20 tournament what India is winner. Okay, then the tournament tree will be like that. India is winner. At first India have to win in the first match, that's India versus Sri Lanka. India will win, that's why India is written here. And after that New Zealand and Pakistan will be in a match, and New Zealand will win, and India and New Zealand will be the play a match, and after that India will in the semi-final. And by this West Indies, Australia, and Australia will come in semi-final, and in the semi-final India and Australia will play, and after that India will be won in the final. Okay, like that you have to make a selection tree. And this is today's video. That's it for today. And after our previous video we are discussing about the traversal of a binary tree. that is pre-order traversal, in order traversal, and post order traversal. Okay.